Hello, ladies and gentlemen. Back again for part two of our first day of discussion of exponential equations. In the first video, I covered three examples. I'm continuing talking about two more examples. Not the way they're solved is the same, but they look a little different than what we've been doing before. All right, so let's start with example number 4. Example number 4, we have log base 3x plus log base 3x plus 6 in parentheses equals 3. So what we want to do here is, remember, we're adding again, so that means we're going to multiply. So we're going to rewrite this as log base 3 x parentheses x plus 6, because remember we're multiplying, equals 3. All right, we do our loop technique and come around, kind of come over this way with it, and make it 3 to the third equals x times x plus 6. All right. Well, let's go and start simplifying. 3 to the third is 27. And then if we distribute the x inside, we're going to wind up with x squared plus 6x. All right, so again, this is starting to look like a quadratic problem because I have an x squared and a 6x. So that means that since it's a quadratic, we need to get everything on the left side, on the right side, so that we can solve using factoring or quadratic formula or whatever else. All right, we're going to wind up with 0 equals x squared plus 6x minus 27. All right, so now let's solve it by trying to see if we can factor it. So I'm gonna come over here and make my x method, put negative 27 on the top and 6 on the bottom. This is my factors of 27, which are 1 and 27, 3 and 9, and that's it. All right, so since the first sign was positive and the second sign is negative, hold on 1 second, let me try to fix that up, sorry. Since the first sign is positive and the second sign is negative, then that means that the bigger number is going to be positive and the smaller number is going to be negative. So I'll put a plus sign by my bigger numbers and minus sign by that. So I get 26 and 6. So my two factors are negative 3, positive 9. All right. So now we're going to come over here and rewrite it as x minus 3 and x plus 9. So to solve this one, we're going to wind up with x minus 3 equals 0 and x plus 9 equals 0. So I'm going to add 3 to both sides and get, sorry, let me erase that little part here, plus 3, and this comes to x equals 3. Over here we're going to subtract 9 from both sides and get x equals 9. All right, so you have to list both answers. Again, like I said, all these answers, when we plug them back into the original equation, will make sense. However, there are some problems that, like I said, I'll address when we get back face to face, and I'll show you some examples of problems that are not, do not make sense when we plug it back in. All right, and our last example is we have log base 2 x plus 3 minus log base 2 x equals 2. So since we're subtracting, we're going to make this log base 2 x plus 3 divided by x equals 2. So remember, when you're subtracting and condensing, we always divide, and we always do the first log over the second log. So now we're going to do our loop technique again and wind up with 2 to the second equals x plus 3 over x. Well, we're going to go ahead and simplify this and make this 4 over 1 equals x plus 3 over x. Remember, we've got to do our cross multiplying. All right, so I'm going to come over here and do it over here and wind up with 4x equals x plus 3. So since there's only, even though there are two x's, there's no x squared term, so this is just a regular linear equation. So we're going to subtract x on both sides and wind up with 3x equals 3, then divide by 3, and then our final answer should be x equals 1. All right? And so that's how you handle the first set of equations that we're going to address in this class. I've assigned a Google form with, I apologize, I know it's 18 problems, but this will give you some time to practice these skills. Also, I don't mind if you work together, but do not be disruptive when you're working with a partner. Some of these answers will have radicals in the answer because you will have to solve it by taking the square root. Make sure if you have a radical in your answer that you will have to use equatio to put in the square root function, the square root notation. Also, some of these answers will be fractions. Some of these answers may be fractions. Please use the Equatio button in Google Forms. This is the blue button to the right to actually enter in your fractions. Make sure that you have completed this assignment before you leave class today. I will be grading it based on completion. So please don't put IDK. Try your best. I will be looking over them and trying to make sure that you have an answer that makes sense. Please don't put decimals, again, because on the test, the answers will not be in decimal form for these types of problems. Thanks for your attention, and I will see you when I return to class. Bye now.